Okay, very good morning to all of you. Um, Give the QR code attendance, then we will start. Okay. My voice is audible to all.
Yes, ma'am.
Okay, Saubhagya, thank you. Give the attendance, then we will start. Okay. Only 6 students are present. Your class, my God. क्या हो क्या गया है तुम लोगों को? हाँ, why don't you attend the classes? I also take electrical classes of 6M. They are not like this. They come to class. At least they are many numbers. I mean, they are 52 of strength, but at least 30 to 35 students attend the class every day. Only fall in attendance I find in your class. 6, 7, 12 students are present. Don't know what's the issue. Okay. So let's start. Okay, in my previous lecture, I think I have discussed with you about the Maxwell bridge, right? So there was a long gap, okay, between my previous lecture and today's lecture. So I think once again, I should recapitulate the Maxwell bridge, okay, and the phasor diagram also. Okay, and then we will move on to the next bridge because the continuation gap is difficult in case of bridges. And in Maxwell, I have told you that there are, though Maxwell measure the inductance, okay, but Maxwell again have two types. One is Maxwell inductance bridge and one is Maxwell inductance capacitance bridge. Okay, so in respect of that, let us discuss once more about the Maxwell. Then we can easily move on to our next bridge, that is Hayes or something else. Okay, so let us come to the Maxwell first. Okay, let me show you one thing. Acha, wait a second, okay? Now others are joining. Wait, let me share my screen with you. Okay, the screen is visible to everyone, I think. So under this Maxwell inductance, okay. Sorry, measurement of inductance. We will go through first the Maxwell inductance bridge once. Okay, others who have joined late, I will show you the QR code at the end of the class. Okay, so wait for them. Now, see this picture nicely. Okay, it's very important to see the picture. First of all, keep in your mind that what is Maxwell used for. So I told you that Maxwell bridge is measured for inductance. Okay, inductance, and it can be used to measure the inductance by comparison either with a variable standard self-inductance or with a standard variable capacitance. Okay, so these two measurement methods are done by two different Maxwell bridge. So I told you we will be learning two things: Maxwell inductance bridge and Maxwell inductance capacitance bridge. Okay, so in this particular, you follow this diagram nicely. Okay, Maxwell inductance bridge diagram. This is important. Now, in this bridge arrangement, the value of the unknown inductance is measured by comparison with a variable standard self-inductance. Okay, so you can see here what are the connections done here. First of all, the connection, if I enlarge this, acha, if you are not able to see clearly this diagram, then you with your fingers, now you can enlarge the picture. Okay, you can enlarge the picture with your finger. Now come to this diagram. मेरे लिए भी difficult हो रहा है इसलिए मैं इसको enlarge कर रही हूँ. Okay, now come to the diagram. See the diagram very carefully. See the connections properly. Actually, okay. Now in this diagram, if I say my this Tanisha. Okay, if I say that in this bridge, I need to find the value of the unknown inductance, okay, by comparing it with a variable standard self-inductance. So in this particular figure, I can see the bridge is under balance condition. So you see here, the bridges I have taken here, see the terminal points clearly. Okay, what are terminals point given? This is A, this is B, this is C, this is D. Clear? Now, two branches BC and CD. Where are the two branches BC? So this is one of the branch BC and this is the second branch BC and CD. They have non-inductive resistance. That means with this, see, follow these two branches here, no inductance is connected, right? So here is only resistance is connected. Here R3 is connected. Here R4 is connected. So I told here that two branches, that is BC and CD, they have non-inductive resistance, that is R3 and R4. I think this is clear to all. Now, one of the arms, if my voice breaks, then please tell me. Okay. Okay. One of the arms, AD, come to AD, which is the AD, this arm is the AD, right? So one of the arms, AD, that consists of variable inductance, that is L2. So what is the variable inductance? L2. And I told you whenever you find, whenever you find this kind of arrow sign, suppose here with the inductance arrow is given like this. That means this arrow indicates that this inductance or whatever, if it's applying resistance, that means that particular parameter is variable. Okay, so on the arm AD, it consists of variable inductance L2 that is having a fixed internal resistance, that is R2. Okay, so here R2 is the fixed internal resistance which is connected in series with the which is connected in series with the variable resistance. Okay, so acha, one more thing I want to tell you here. Let me show you the internal resistance first. Wait. Acha, here with L2, it is having an internal resistance called R2. Sorry, wait. That is missing somehow here. I forgot to write. R2 is the internal resistance for this variable inductance L2. Okay. And it is connected with the variable resistance capital R. This is not the internal. Internal is small R2. Okay. Which is connected internally with this particular inductance. Now come, we have discussed with the arm BC, with the arm CD, and with the arm AD. Okay, the remaining arm is the AD. So this is my remaining arm, and my remaining arm AB consists of unknown inductance. See here, the unknown inductance, that is LX. Okay, so I'm writing LX. And here the unknown resistance is Rx. Okay, so both things are unknown to us. So here the remaining arm consists of unknown inductance Lx of resistance Rx. So a source of current is applied here, okay, to the two opposite junctions across where? Across this AC. Where is the AC? Here is the A, here is the C. So across the AC, and the null detector is connected to other two junctions BD. So where is the detector connected? See, here is the detector connected with the terminals. Here is B and here is D. So I think this whole picture is clear to you. Where what is connected, it is important. And what the terminals name you are taking, that is important. Okay. And see, two arms are completely free from inductance. That means they are completely resistive, and other two arms are having the inductance. So one of them are having variable inductance with internal resistance small r2, and another one is having inductance, but that is unknown. Okay, so and the connection you see here, current is applied between A and C, and detector is connected between B and D. So these are my terminals. Okay. Now, if I try to say that what will be the impedance of my four arms? So this thing I have also told you in my previous class, but let's recapitulate once. So if I say that, let me also show you the, let me once see where the down is. Yeah. Okay. So here you come to see, wait. Let me clear everything. So in this particular diagram, I will also show you the phasor diagram. So let me show you that once, then we will discuss. See here. This is the phasor diagram of that particular diagram which we did just now. So in this phasor diagram, we are denoting it with actually the E1, E2. See here in the previous diagram, I have denoted that what is this is the E1, this is the E3, this is the E2, this is the E4. Okay, so E is actually the supply. So where what supply is going? So phasor diagram is dependent on that, on the positioning of the E. Now this E1 is equal to E2. Why? Because it is on the same side. So similarly, on the basis of that, we will draw the phasor diagram. Don't worry, I will share this with you. So just follow what I'm saying. So when I'm drawing the phasor diagram, I try to do it that E1 is equal to E2 because these two are parallel to each other. Again, E3 is equal to E4. These are on the same side, same arm and parallel to each other. So I will try to draw the E1, E2 and E3 for in such a way that is look like that. Okay. So how come? So let me show you. It's an easy diagram. So first of all, wait. Come to this diagram. Here in this particular diagram, how you have to draw, that is most important. See, first we are trying to draw this kind of structure. First we will draw only this kind of triangle. Okay, up to this. Okay, this kind of triangle is okay. Now, in this particular diagram, I can write this part as E1 equals to E2 and this part as I1 equals I1 R1. Because in E1, what is the resistance and current? That is I1 R1 is flowing. Here you keep it the unknown part. Okay, the unknown part that is Rx. We can also take it as R1. So for phasor, we are taking it like this. And another, you can take it I1 X1. Okay, so this is totally optional that how you're taking. Now we can extend this, see, whatever we have done with this line, we have drawn a parallel line here. Okay, and with this respective line, we have drawn a parallel line here. Okay, so if you remember the mathematics, whatever we have done, that this line is parallel to this line. Okay, and this line is parallel to this line. See, exactly in that way we have drawn it. And the second thing is that if you remember the vector quantity we have learned in physics also, right? So what we do in vector, we in this kind of structure, if we get, we try to find the resultant also. Resultant will be right in this direction, right? In vector, in physics, in 11, 12, if you have learned nicely, then you can understand whatever we are writing. Suppose if here we write E1 and here we write E2, but our resultant vector will be this one. This is our E. Okay. And then we try to join this thing. So E will be E1 plus E2. So it's a resultant vector which give a summation of other two vectors. Okay. So it's a vector. So I'm writing E cap, E1 cap, E2 cap. This will be E cap. So that vector concept also come here. That this middle line I have drawn up to here, that is also see written here E. It's a resultant value. And the other two what I have drawn, that is just to make the diagram. I have drawn parallel lines I have drawn. Suppose with this one I have drawn this parallel line and with this one I have drawn this parallel. And I told you that E1 equal to E2 and again here E3 equal to E4. Okay, so in that way we have drawn, and we also know that with respective E3, what is flowing? Obviously, I3 is flowing. Again with again in E4, what is flowing? So here in this particular line, I can also write that I1 is flowing, I2 is flowing. Okay, in this particular, and again from the previous thing, there I told you one thing that I1 R3 is equal to I2 R4. This thing we will derive also. Okay, so don't worry, this thing we have done also. And in Maxwell, we also have some particular equation. So this diagram is very easy, that you have to just draw the E1, E2 and all these, and you have to just take the parallel lines and the resultant. Okay, so in various books also you will find this kind of things. Now let us come to the derivation part. In derivation part, let me clear one thing. derivation part. First of all, you need to know that what are the impedance of your four arms. Can you tell me what is the impedance of Z1 arm? Come to Z1 first. What is my Z1? My Z1 will be this one. Okay. So Z1, according to me, it will be Rx. Okay. I'm taking Rx plus it will be J omega Lx. If I'm wrong, then tell me. Okay. J omega Lx. I think this is clear. J1. Acha, now tell me what J2 I can write. J2. Hello. Pooja. So Ayushi, are you there? Ehtesam?
Yes, ma'am.
Yeah. J2, what can I write? J2. Just like J1.
R2 plus J omega L2.
Yes, but I need to also include the internal resistance, right? I told you that L2 is having an internal resistance R2. Okay, so that I also need to include. So R2 plus small r2 plus J omega L2. Okay, just like this. Okay, thank you. Next, come to Z3. Z3 will be simple, just R3. Okay, and Z4 will be also simple, that will be R4. So this 4 impedance, I think you're able to understand how I'm writing. Now, I need to balance it, right? What are the balance equations? The balance equations will be Z1, Z4 equal to Z2, Z3. Okay, so Z1, Z4 equal to Z2, Z3. Okay, so Acha, I am opening my whiteboard because it will be difficult for me to do here. Okay. So in my Z1, Z4 equal to what? Z2, Z3, I told you, right? Z2, Z3. Now, what is Z1? Z1 is definitely Rx plus J omega Lx, okay, multiplied by R4. Clear? This is my Z1, Z4. And what is Z2? Z2 is R2 plus internal resistance small r2 plus J omega L2, okay, multiplied by R3. So this is my equation coming. So if I open the equation, if I try to solve it, then what it will come? Rx R4 plus J omega Lx, okay, J omega Lx R4, that will be equal to, I will take the resistance together, R2 plus internal resistance R2 together, okay, and then I will write definitely R3 plus J omega L2 R3. Okay, so this is my thing. This is my required equation. Now, if I try to equate the real and the imaginary part of equation, then what I will do here, I will take this Rx, R4 and R2 this together and this imaginary part separate. Okay, and this part separate. So let me do that. So now I will equate these two parts. So what I'll get? So Rx I will get simply, it will be according to me R3 divided by R4, okay, R2 plus R2. This is my Rx I got, okay, this is my Rx. And from here, I will get the Lx also. So what is my Lx from the imaginary part? I think it is R3 divided by R4 L2. R3 divided by R4 L2. So this is my Rx, this is my Lx. I think these two things are clear. So Rx and Lx I got finally. So I know. So we observe that two conditions for balance equations here. That is, this is one equation. This is one equation, balance equation. And second is this equation. Okay. So these two equations are important. And from this equation, we are able to understand what is my unknown resistance and unknown inductance. So by comparing and the variable inductance, definitely L2, okay, and small r2. So small r2, as I told you, it can be also called as decayed resistance box. This small r2 can also be called as decayed resistance resistance box. Okay, it is called as. Okay, so I think this much thing is clear to you all. So this thing is all about Maxwell inductance bridge. Okay, now let us move on to Maxwell inductance capacitance bridge. So first of all, let me share with you what I was telling you. Okay, so this is clear. Now let us move on to our next. Some advantages are there. So let us complete that. So advantages are simple. Just go through once, and disadvantages definitely are there. Variable inductor is costly. This is the one more thing. Okay, so this thing, and it's very bulky also. So that is why we always try to go for a better bridge. Now let us move to this Maxwell inductance capacitance bridge. Look into the diagram nicely. The diagram is very important. Okay, this is mainly important. Look into this diagram, and whatever I'm telling, listen to it carefully. Now, here also, in this particular diagram, what we are having, we will take this as Lx, okay, and we will take this as Rx. Clear? And okay, so see here in this bridge arrangement, what we can see that the value of unknown inductance is measured. So this arrangement is all about Maxwell inductance capacitance bridge. Okay, and here the unknown inductance we need to measure by comparison with a variable standard capacitor, because it's a inductance capacitance bridge. So in this figure, again, I'll show you the phasor also. So two arms, just you come to see here, two arms, that is this BC, this one arm, that is this one BC arm, and this AD. Where is the AD? This arm. This BC arm and the AD arm, they are purely non-inductive. Okay, non-inductive. Why? Because they have only resistance of R3 and R2. So keep in your mind, first of all, in this particular diagram, you have to identify that which arms are purely non-inductive, okay, and purely resistive. So here these two arms, this BC and AD, they consist of the non-inductive resistance R2 and R3. Now come one of the arm, that is AC. Come to AC, which is the arm AC. Wait, yeah, one of the arm, that is AC. It consists of, see here where the C4 connected, C4 is connected in the CD terminal. So you see here the CD terminal, C4 is connected in parallel to a non-inductive resistance R4. So here is the R4, here is the C4, and this is my CD branch or CD arm, you can see. So in this particular arm, this C4, that is the capacitor, you can call it as a variable standard capacitor because here arrow is connected. So it is called variable standard capacitor. It is connected in parallel with to a non-inductive resistance, that is R4. So the remaining arms, so I have discussed till now with BC, CD and AD. Now what is my remaining arm? The remaining arm is my AB. So come to see here AB. AB consists of the unknown inductance, that is Lx, and the effective resistance, that is Rx. So, and you can see a source of current that will be flowing across AC and null detector connected across this B and D. Okay, and here E is a supply. So this is E1, this is E2, this is E3, this is E4. So this is the thing actually picture. So here again you have to take into account, say similarly, the impedance of the four arms. So before going to that, let me show you the phasor diagram once more. Yeah, this is the phasor diagram. Come here. I'm clearing all this, the phasor diagram. See, similarly, just what we have done in case of inductance, similarly here also, similar kind of picture they have tried to draw here. Okay. So this is the phasor diagram for Maxwell capacitance. Only here, due to capacitance, a single two triangles have been formed here. One is this one triangle for the capacitance part, another this triangle for the inductance one. Okay, so just this, otherwise the thing is similar. I mean, this portion, this line we have drawn parallel to, I mean, this line have been drawn with a dotted line parallel to this line, and according to this line, this dotted line have been drawn. This is the resultant E. Okay, so in this way we have tried to draw the Maxwell phasor for inductance capacitance. Now let me share with you my whiteboard where I will show you for the Maxwell capacitance. Let us discuss Maxwell. I'm writing here L by C method because that is denotes the inductance capacitance bridge. Okay, inductance capacitance bridge. Now let me tell you, first of all, what we have. First, so let us discuss the 4 arms. So for Z1, I can write here. For Z1, I will write here Rx plus J omega Lx. Okay. So I think you are understanding this portion. Z2, I can write here R2. If you follow my diagram, it will be clear to you. For Z3, I can write, I told you that 2 arms are simply resistive arm. And for Z4, you will be able to write, if you follow the diagram, you can see that R4 is parallel to variable capacitance, right? So it will be just like this, J omega C4. Okay, J omega C4. So it will be like R4 divided by 1 plus J omega C4 R4. Okay, so this is my 4 arms what I got from my Maxwell inductance capacitance bridge. Now you try to balance the equation. So in balance equation, what we know for balancing purpose, we know the equation is, if we try to balance it, Z1, Z4 will be equal to Z2, Z3. So this is my balance equation formula. So now I will try to put the values here. So if you try to put the values here, what you will get Z1? Z1 is Rx plus J omega Lx. Okay. And Z4, you know, Z4 is again R4 divided by 1 plus J omega C4 R4. Okay. C4 R4. Next, you see what is Z2? Z2 is R2 and Z3 is R3. Okay. So I think this much is clear to you all. Next page I'm moving to. Now I need to solve it. So after solving, you will get something. After solving this equation, some let me see what you will get. Yeah, you will get some Rx R4. Okay, Rx R4 plus J omega, you have Lx Rx, that will be equal to R2 R3, okay, R2 R3 plus you will get J omega C4 R2, okay, R3 R4. So this kind of something you will get, okay, from one equation. So now we again have to segregate the imaginary and the real part. So from that we can get Rx will be equal to R2 R3 divided by R4. So this is my 1 numbered equation. Okay, my unknown resistance is done. Now come to unknown inductance, that is Lx. It will be similarly R2, okay, R2 R3 C4. This I will get as Lx. Okay, so from the above conditions of the balance bridge, the unknown inductance value is determined by comparison with the variable standard capacitor. So you see here, you can find the difference in case of, I'm taking you back, in the case of only without capacitance, only Maxwell inductance, there was no capacitor term. But in case of here, in case of Maxwell inductance capacitance, you can find the capacitor term here. This is a C, okay, C4. So now come, now you have to determine also the quality factor of the coil. So let us decide that quality factor of the coil. Q you have to determine. So that will be Q equals to write down omega Lx divided by Rx. So this is the quality factor. So you know what is Lx, you know what is Rx, right? From the above equations 1 and 2. So you have to just put the formula. So omega Lx means R2, okay, R3 and C4, right? And Rx I can see R2, R3 divided by R4. So this is my Rx. So if I do the cross multiplication and all, so I think I will get quality factor that is equal to omega R4C4. Omega R4C4. So this will be my due equation. So my quality factor will be this one. Okay. Omega R4C4. So this is my Q. So this is all about advantages. There are definitely, what are the advantages? That is important. That this is a balance equation. It is independent of the losses. Okay, with the inductance, frequency does not appear. Yes, who?
मैम वो सेकंड इक्वेशन कैसे आया मैम, समझ में नहीं आया मैम। Lx आप निकाले तो वहाँ पे R4 भी होगा ना मैम?
ओ
R2 R3 R4
Lx na, wait, imaginary part na, Lx,
Yes,
j omega, yeah, sorry, I missed out, यहाँ पे R4 भी आएगा, is imaginary,
तो
yeah,
मैम वहाँ पे भी चेंज होगा क्वालिटी फैक्टर।
हाँ, quality factor में change होगा, wait, R2 R3 R4, yes, R4 आएगा, अगर यहाँ पे भी मैं R4 लेती हूँ मान लो, ठीक है, right? If I take here R4, then see what is the quality factor coming. तब तो ये quality factor नहीं आएगा, तब तो कुछ अलग होगा, right? So what is the Q coming?
मैम R4 का स्क्वायर हो जाएगा।
Yes, R4 का स्क्वायर हो जाएगा. Wait, इरेजर को हटाते हैं. Okay, R4 का स्क्वायर हो जाएगा and omega will be there. R2 R3 will cut down, right? तो रहेगा C4 R4 स्क्वायर हो जाएगा, right? ऐसा आएगा? हेलो? ओके,
यस मैम,
ठीक है, थैंक यू सो मच ये बता देने।
मैम
यस बोलो।
हम वहाँ पे R4 प्लस जे ओमेगा Lx R4 होगा जब हम लोग मल्टीप्लिकेशन करेंगे।
मतलब कहाँ पे?
मैम वहाँ पर आप गलती से Rx लिख दिए।
मैं Rx लिखी हूँ? कहाँ पे बोलो तो Rx लिखी हूँ?
हम फर्स्ट इक्वेशन में Rx
equation?
R4 प्लस जे ओमेगा Lx Rx।
अच्छा, ओ हाँ, this will be R4, this will be R4, this one, wait, ये, right?
Yes ma'am.
Yeah, this will be R4. See, now it is correct. Now, if it is, wait. If it is, if I try to now, j omega R4, एहतिसाम, ठीक ही तो किया था मैंने।
मैम ओनली R2 R3। मैम तो Rx तो R2 R3 हो जाएगा ना फिर?
एक मिनट
मैम Rx R2 R3 हो जाएगा ना?
वेट, क्यों Rx R2 R3 क्यों होगा? वेट, ये है Rx R4 और ये है R2 by R3, तुम इन दोनों को इक्वेट करो तो Rx ठीक ही है यार।
हाँ ठीक है
और ये j ओमेगा Lx R4 यहाँ पे R4 will cut out,
हाँ तब
तो
हाँ
फिर
तब सही है,
गलत बोले।
R4 कट जाएगा।
हाँ, so I did right thing, you confusing me। हाँ अब ठीक है, देखो R2 C4, तो फिर जाके मैं जल्दी से ठीक करती हूँ वरना ये गलत हो जाएगा। So so I did the right, so here it is okay, so here also R4 is not required, so it will cancel out, so automatically I am getting the answer omega C4 R4. This will be my correct answer, omega C4. This is my quality factor Q, and this is important. Okay, so थोड़ा imaginary और real part इनको थोड़ा ध्यान से देख के करना, ऐसा वरना गड़बड़ हो जाएगा। So my C4 R4 is my quality factor, Q factor. Okay, so it is important. Short questions के लिए बहुत important है। अच्छा, one more thing, I want to tell you the advantages. That is the frequency does not appear. You have seen we have not deal with any frequency here, and it is very useful for measurement of wide range of inductances at power and audio frequency. Okay, so don't worry, I will share these notes with you as soon as possible of these bridges. So, and videos to upload ho hi jayega, then you can able to see also that what are the derivations we have done for Maxwell. So Maxwell I'm done. So from next in the next class we will start tomorrow. Tomorrow I have class with you. So tomorrow I will start the next bridge, that is Hayes or something. Okay, once I want to share the QR code with you who have not done the QR code. Wait. और ये प्रैक्टिस करना ये सारे ब्रिजेस इट इज इम्पोर्टेंट क्योंकि ये जितना प्रैक्टिस करोगे उतना अच्छा होगा. Okay. The class is not so boring, I think, but I don't know why your friends don't join. Okay, ये derivation करोगे तो भी तो interesting लगता है ना. मैं तो सिर्फ theory नहीं बोलती हूँ. I not only say theory in this class. So I don't know why your friends don't join. Only 12 students are there. See, it's not that boring. I feel so. Okay. Okay, take it down. Then from tomorrow we will start Hayes Bridge, and I will try to share these notes, okay, as soon as possible. Okay, so any query from any other people, then you may ask me. Asad to you join very late. Okay, you join very late. Every time you come late. Manorama and Saubhagya, Sushila, if you have any confusion, ask me. At least जो हो यहाँ पे वो तो पूछो. Okay, so thank you so much, and if you don't have any query you can leave the class. We will meet tomorrow in the next class. Okay.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am.
Thank you.